Hey everybody, this is Larry. This is day 26 maybe of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Yeah, I am right now in, I don't know, you can't tell, Copenhagen Airport. That's probably a name for the airport, but I'm here en route. So I'm gonna just, we have a hard problem today, is that right? I was gonna say we'll make it quick, but thanks Leetcode. Let me see. But yeah, I'm still traveling and I have about an hour to my flight, so hopefully I get to actually I'm gonna move to the desk. But yeah, so I have an hour to my flight, so we'll see how much I can get done before that happens. There was like a table here, so I will use the table since this is not an easy problem. Okay, so yeah. And also maybe if I'm a little bit soft spoken because I don't want to be so loud. It's actually really quiet in here, so I don't know. All right, let's see. We have 2444 count subarrays with fixed bounds. Okay, min k, max k, right? The minimum value of the subarray is min k, maximum value is min k. Return the number of fixed value mint. What does k mean? What is min k? The minimum value, okay. So the minimum value is okay. Let's see how I want to do this. I mean, I think this is the similar idea to all the problems we've been doing this week, right? It's this idea of contributions and try to figure out, okay, if this number is the last number or in the last element in an array, what can we do, right? So for example, what I mean by that is that let's say you have this array, right? If 5 is the last element, how many subarrays are the left side of the element, right? The right side is 5, the left side, how many of them, right? And in this case, it's tough to say. Is it though? I'm also trying to think, right? Like, wait, no, I misread this. Oh, because initially I was like, the minimum is at least just not equal to. So equal makes it a little bit different, and max also makes it a little bit different, right? Because I was like, oh, can you just limit it by like the numbers that are not in range, right? Because for example, in this case, we have a 7, we'll just remove the 7, and then you just can't count the number of subarrays, right? But no. In this particular problem, you have to be exactly 1 and 5. I mean, we still have to kind of parse out the 7 because in this case, that would never be part of the answer. And then now we have these sub-problems in which all the numbers are within bound. And then now we can figure out how many ways are there, right? Maybe that's a little bit easier. So the first thing we do is we'll divide this problem into an easier sub-problem. Okay, right? So let's say we did the thing. We break them apart into such that every chunk, the number is inclusive between min k and max k. Okay, so let's say we have that, right? Then now what? Okay, so here, I'm trying to think whether it's I mean, I think the approach that I was saying still makes sense. So let's say we delimited, right? Then now here, if 1 is the min k, then the min k is satisfied, but the max k is not, right? Don't know what that means, okay? And then now 3, same thing. 5, now we have the min k and the max k, right? And that means that everything now to the left of the 1 is a degree of freedom, and everything to the I want to say that everything to the right is the degree of freedom, but then you might risk a chance of double counting, right? For example, if you have like another 1, 5 in the future, if you just say like, okay, if we take the first 1 and the first 5, and then you go extend it all the way here, well, that is still a good subarray, but you're double counting it if your last element is 5. This is why we want to be really constrained about the 5 part. But then now if we go to 1, then we just have to be like, okay, the last element that we saw because this is the min, the last max that we saw is 5, then we can just degree of freedom over that way. So you kind of keep on doing that, and I think that should be enough. I think there is an additional case where min, depending on how you program it, how you implement it, where where the min k and the max k is the same, then maybe you don't want it that way, right? Or like you have to handle it a little bit differently. So, but I think that part is actually the same problem as, yeah, that we've seen something similar, right? So maybe we'll do that first because it's easier, right? So with min k is equal to max k. My apologies again if I'm not being precise or explain it very detailed, because I'm in an airport. I'm trying to make sure that I don't miss my flight. It is what it is, right? So if they're the same, then it just becomes a very straightforward. Well, first we still have to partition it by, right? So we have maybe chunks is equal to, so we have a function that takes nums, right? I think you could actually, maybe I don't even need that, right? I think you can do a group by. So group by of nums where the, I forget the syntax, but I think the key is where the x is where x element is within the thing, right? So we could do something like this, right? So here we have gt and I forget. So if g is true, then we just do we append it to a list of t, right? So there you go. So now we have these chunks, and then if min k is equal to max k, then all we have to do is just for each chunk, for chunk in chunks, we let's just say total is equal to 0. Total is equal to we add self same, right, of chunk, and then we just return total, right? And maybe we have self same here. So for a given chunk, we go, okay, so previously seen is equal to 0. So then for x in chunk, if x is equal to min k, we increment previously seen by 1, and then now total, we just add the number of previous seen number, right? And this is just by counting, right? Because if I do want to draw it out, but I am rushing it a little bit, not gonna lie. But let's say you have something like this, or actually, yeah, and we have other numbers as well. In this case, it's a little actually. I'm wrong. If they're the same, then it cannot have any other number, right? So actually, I think I overcomplicated. I mean, this is kind of right, but it's still I overcomplicated it a little bit because this will always have to be true. So then you have this, which then now you could reduce it to like the n choose 2 type number, right? So it's like, but I'm gonna keep it this way just for funsies, right? So you could kind of run it real quick. So yeah, so this is right. I mean, you know, and you can also have right, something like that, and it should be like 20 or something, unless I mistypoed it or whatever, but it should still be right, right? So there you go. Okay, so then now the other thing is they're not the same, right? So maybe we have a sub difference of a chunk, and we have to kind of write this as well. That battery, 95%. I'm actually pretty good. I actually didn't pay attention though. I think I have a plug here, so it should be fine either way. But yeah, sorry if I'm not speaking loud enough. I'll double check the voice level and maybe artificially increase it later. But yeah. Okay, so then now we have a chunk. I think it's just like we said, right? So last min seen is equal to none. Last max seen is equal to none. And then for x in chunk, if last min seen is equal to, oh oops, if x is equal to min k, then last min seen is equal to index. I have to enumerate this, right? If x is equal to max k, then last max seen is equal to index. And then now the degree of freedom, and I'm probably rushing this a little bit, but let's say you have something like this, and this is what we kind of ran over earlier, right? So here, if you had this 5, then now you want to take the min of these two indexes, right? Because your two indexes are here and here. Then you want to take the min of those two because that's the earlier one. And then the degree of freedom is how many numbers are before it so that you can choose, right? So here maybe we will have something like this, and then yeah, and if last min seen is not none and last max seen is not none, then total will be added by min of last min seen and last max seen plus 1, I think, right? Because it gives you 1 away regardless. And I think that should be roughly right. Maybe I'm a little bit off, and I'm a little bit sketchy about the proof, but I'm going to go to submit because I'm at the airport. What else do I have to lose? Oh, actually that was honestly a little bit faster than I expected in the south. Am I happy about this? Probably. I mean, everything is linear, right? There's a linear loop here, linear loop here, linear loop here, and then inside there's a linear loop inside those linear loops. But keeping in mind that it's not n squared in the sense that for each chunk, we look at each element once or twice, right? So you kind of go by chunk, and then within each chunk, you go one element by one element. Each element only get looked at once. So this is linear time, linear space. And yeah, I'm gonna call it an early video because, like I said, yeah, need to, I don't know, because right now it's very quiet, but I also don't want to overstay my welcome, and also it may get loud anyway as the flight gets a little bit closer. So yep. Anyway, thanks for watching, and yeah, stay good, stay healthy, do your mental health. I'll see y'all later and take care. Bye bye from Copenhagen.